Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video examines the effect of clustered data points on linear regression. Let's get started. So here we have an example problem where we've got data that's appearing in clusters on our scatter plot. So you've got 9 data points over here that come from women and 9 data points over here that come from men. What they represent, we're not really told, but that's not material to the question at hand because look what we're asked. What's the value for the linear correlation coefficient for just the data points that come from the women? Do the same thing for just the men. Then we do all the data points together, and then we look at these results and say, what do we conclude? Should the data be considered to contain 2 distinct populations, or should they be considered together? We can do this, we just take one question at a time. So first, let's look at the data points for just the women. If you're not given any sort of link to dump the data directly into StatCrunch, you're going to have to put that data in yourself. So up here, just take in each data point one at a time. This first data point here, its x value looks to be between 0 and 2, so it's going to be 1, and then between 2 and 4, that'll be 3. So 1, 3, notice here, coordinates for the first data point. Going to finish that out for the other 8. And then go into Stat, Regression, Simple Linear, select your x and y's, press Compute, and out comes this results window. And you can see here, our R value is going to be 0. So there's the answer to the first question. We do the same thing for the men. Go through the same process. So notice I just moved over a couple columns there and I just put everything there with the men. Same process of getting the points for the individual data points and go through the same menu options, and notice the results come out the same for my R value. Again, my R is 0. This typically happens when you have, geometric, structure there, like a square that, everything's equidistant from the center, more or less. So, the way R is calculated, everything cancels each other out and you end up with 0. So R will always be 0 when you get your data points that are geometrically symmetrical along both axes, like a square. Now, here, for all the data points put together, just go ahead and just, copy those all out. And I just put them under, 2 separate columns, just a general X and Y. Go through the same steps, get your results, and look here, we've got a different value for R this time, 0.483. So we actually have something here for R. Now the last question asks us about, should we consider these to be 2 distinct populations, or should they be considered together? The R values aren't really helpful for helping us to answer this question. What is helpful is a scatter plot. Notice how there's no real overlap here between the data points that come from the women and the data points that come from the men. They seem to be congregated off amongst themselves. There's no overlap or interplay between those 2 areas on the scatter plot. And so therefore, we're showing 2 distinct populations here, which means because you're looking at 2 distinct populations, you should not combine them together to do an analysis for a relationship. To do so would be very, very misleading. So you want to keep them separated when you do your analysis. So here's one, here's the second. You can see they're 2 distinct areas without overlap. So yeah, keep them separate. Do an analysis on each population individually. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.